everyone! In this video, we're going to complete the KutaSoftware Infinite PreAlgebra free worksheet, Powers of Products and Quotients. Our directions for this worksheet are to simplify. Your answer should contain only positive exponents. So let's dive in to number 1. For number 1, we have 3a squared. That entire quantity, because it's within parentheses, we're going to be cubing or raising that entire quantity to a power of 3. It means that this power of 3 is going to be applied to everything within these parentheses. And because it's multiplication, we're just going to distribute straight on through. If we had addition, for example, if we had 3 plus a squared cubed, we cannot distribute this exponent through to each because these terms are added. We cannot just distribute. We would need to write this out as a polynomial, 3 plus a squared times 3 plus a squared times 3 plus a squared, because that is 3 plus a squared cubed. It's multiplied together 3 separate times, and then we would need to expand and FOIL with each of those terms. But because it's multiplied in number 1, the 3 is multiplied to the a squared, we can indeed just distribute that exponent through. So we can rewrite this as 3 cubed times a squared cubed. So notice all I did was take this exponent and distribute it to the 3 and to the a squared. So 3 cubed we can simply just write out. 3 cubed is 3 times 3 times 3, which 3 times 3 is 9, and 9 times 3 is 27. So 3 cubed is equal to 27. A squared cubed, how exactly do we do that? Well, if we remember from our previous worksheet where we went over multiplying with powers, a squared, that quantity cubed, we can write as a squared times a squared times a squared. So we would need to add those exponents together. A to the 2 plus 2 plus 2, which would be a to the 6th. But there's an easier way to think about it. Think, we added 2 together 3 separate times. So if we have something with an exponent and we're raising it to another power, we just multiply the exponents. So we can rewrite a squared cubed as a to the 2 times 3, which gives us the result of 27a to the 6th. So remembering this, let's go ahead, work through the odd problems, and then we'll go back up and work through the even problems. So moving right down to number 3, we have 3x to the 4th raised to the 4th. We're going to start by distributing this power of 4 to both the 3 and the x to the 4th, since they are indeed multiplied. So this is going to equal 3 to the 4th times x to the 4th raised to the power of 4. 3 to the 4th, well, we know 3 cubed from up above is 27, so we just need to do 27 times 3, which 27 times 3 is going to give us 81. Now we need to do x to the 4th raised to the power of 4, which remember, all we need to do is multiply those exponents. Again, to see this worked out, x to the 4th raised to the 4th is x to the 4th multiplied by itself 4 times. So this is x to the 4 plus 4 plus 4 plus 4, which is x to the 4 times 4. So all we need to do is multiply those exponents. X to the 4 times 4. So this is going to be 81x to the 16th. And that's our solution for number 3. Moving right along to number 5, we have 7 times y to the 4th squared. Again, distributing this exponent through to the 7 and to the y to the 4th. Each of those the coefficient and the term of y. So we're going to have 7 squared times y to the 4th, that quantity squared. 7 squared, we know, is 49, and y to the 4th squared is going to be y to the, what do we do to those exponents? We multiply them together. So this is y to the 4 times 2, which is going to give us 49 times y to the 8th, since 4 times 2 is 8. Moving on to number 7, we have an extra term that we didn't have up above. We have another variable, but because each of these are multiplied together, we can distribute this exponent of 3 to each of our terms. So it's going to get distributed to the 2, it's going to get distributed to the x to the 4th, and also distributed to y to the 4th. So this can be rewritten as 2 cubed times x to the 4th cubed times y to the 4th, that quantity cubed. So working through each of these, 2 cubed is 2 times 2 times 2, which is 4 times 2, or 8. X to the 4th cubed, what do we do to those exponents? We multiply them. So that's going to be x to the 4 times 3. And then for y to the 4th raised to the power of 3, what do we do to those exponents? We multiply them together. So y to the 4 times 3. This all simplifies down to 8 times x to the 12th times y to the 12th, because 4 times 3 is 12. Let's move on to number 9. Number 9, we have x squared times y squared, and then that entire quantity squared. So distributing this squared to x squared and to y squared, we're going to get x squared, that quantity squared, times y squared, that quantity squared. What do we do to those exponents? We multiply them. So this is going to be x to the 2 times 2 multiplied by y to the 2 times 2, which is x to the 4th times y to the 4th. And that's our solution for number 9. If we wanted to look at this a different way, think about x squared times y squared squared. That's taking this quantity and multiplying it by itself. That's squaring it. So we're going to have x squared times y squared multiplied by x squared times y squared. Finding those common bases of x, we would have x to the 2 plus 2 multiplied by finding those common bases of y to the 2 plus 2. X to the 2 plus 2 is x to the 4th, and y to the 2 plus 2 is y to the 4th. Same exact result, looking at this from a different perspective. And again, this method was on a previous worksheet where we worked with multiplying with powers. So I'll leave a link or a card somewhere over here, again, if you want to review that video. We also did one with division as well, if you want to check that out. But for now, let's just move right on down to number 11. For number 11, what are we going to do? Distribute this exponent to each of the terms. So we're going to have u to the 4th, that quantity squared, times v to the 3rd, that quantity squared. U to the 4th, when we square that, that's u to the 4 times 2. And we're going to be multiplying that by v to the, multiplying those exponents, 3 times 2. So this is going to give us u to the 8th times v to the 6th, because 4 times 2 is 8 and 3 times 2 is 6. Moving right along to 13, remember we're going to need to distribute this exponent to all of our terms. So we would need to distribute it to the 3x squared, and we need to distribute it to the 2x squared. When we distribute it to the 3x squared, we need to distribute to the 3 and the x squared. And when we distribute to the 2x squared, we need to distribute to the 2 and the x squared. So let's go ahead and work this through distributing our exponent of 2 to each of the terms. So starting with this coefficient, we're going to square it. So we'll have 3 squared times x squared squared times 2 squared times x squared squared. Working this all out, 3 squared is 9. That gets multiplied by x squared squared, which is x to the 2 times 2, or x to the 4th. That gets multiplied by 2 squared, which is 4, times, again, x to the 2 times 2 is x to the 4th. Simplifying this down, well, we can still combine some terms. 9 times 4 is 36, and x to the fourth can be combined with x to the fourth because they're the same base. X to the fourth times x to the fourth is x to the 4 plus 4. So this all simplifies down to 36 times x to the 8th. I want to note another way that might have been easier to solve this, or a little bit quicker. We could have noticed that we have the same bases, and we also have coefficients that can be combined together at the start. So 3 multiplied by 2, we could have written that as 6, and then x squared times x squared is x to the 2 plus 2, or x to the 4th. So we could have 6x to the 4th, and then square that. So now working with this, as opposed to working with all of this, is a little bit easier because we just distribute this 2, that exponent, to our coefficient of 6 and to our x to the 4th. So we're going to get 6 squared times x to the 4th squared. 6 squared is 36. X to the 4th squared is x to the 4 times 2, which is x to the 8th. So you can see we get the same exact result with a little less work. So let's simplify down first when we go to number 15. In number 15, you can see we can indeed simplify down because we have 2 bases that are the same, those bases of n. So I'm going to rewrite this problem as we only have that one coefficient of 4, and then we have this coefficient of 1. 4 times 1 is just 4, so I'll write this as 4, and n cubed times n squared is n to the 3 plus 2, and we have this entire quantity is squared. So continuing to simplify down, inside, when we add that exponent together, we'll get 4 times n to the 3 plus 2, which is n to the 5th, and we're going to square that. Now, let's take this exponent of 2 and distribute it in. So we're going to get 4 squared times n to the 5th squared. 4 squared is 16, and n to the 5th squared is n to the 5 times 2, which is n to the 10th. Moving right along to number 17, the last of our odd problems. We have 4x to the 4th times x to the 4th, all of that cubed. Let's simplify down at the start because x to the 4th can be combined with x to the 4th. So we can rewrite this problem as 4 times x to the 4th times x to the 4th is x to the 4 plus 4. Again, we add those exponents together when we have bases that are the same, that are multiplied together. And then this entire quantity is cubed. Simplifying down, we're going to have 4 times x to the 4th plus 4 is x to the 8th, and that is all cubed. Distributing this exponent of 3 to both the 4, our coefficient, and our x to the 8th, we're going to have 4 cubed times x to the 8th cubed. 4 cubed is 4 times 4 times 4, which is 16 times 4, which gives us 64. And x to the 8 times 3 is going to be x to the 24th. So there we have it. That last odd problem, 64 times x to the 24th. If you've been finding this video helpful so far, don't forget to click that thumbs up button. But for now, let's go back over to the even problems, starting with some easier problems and working our way down to the more advanced problems. So back up to number 2, we have just this one term where we have a coefficient of 2 and n to the 4th. We know that we need to distribute this 4 into both the 2 and with n to the 4th. So we're going to have 2 to the 4th times n to the 4th, all raised to that power of 4. 2 to the 4th is 2 times 2 times 2 times 2, which would be 4 times 4, which would be 16. So we get 16 times n to the 4th raised to the power of 4, which is n to the 4 times 4, because what do? We multiply those exponents when we're raising a power to a power. So n to the 4 times 4 is going to be n to the 16th. So for number 2, we've got 16 n to the 16th. Moving right on down to number 4, we have 6 times b squared squared. So we're going to take this 2 and distribute it to both the 6 and the b squared, since these are indeed multiply. This coefficient is just multiplied to the b squared. So we're going to have 6 squared times b squared squared. 6 squared is 36, and b squared squared is b to the 2 times 2, because we multiply those exponents. So this is going to be 36 times b to the 4th for number 4. Again, if you wanted to write it out, expanding out this problem, we would have 6b squared multiplied by 6b squared. 6 times 6 is 36. B squared times b squared is b to the 2 plus 2. 36 b to the 4th. Writing out this answer from a different perspective. Let's move on to number 6. Number 6, we're throwing another variable into the mix. So now we're going to need to distribute this 4 to the 3, which is the coefficient, to the a, which is multiplied by 3, and to the b to the 4th, which is multiplied by a. So we're going to have 3 to the 4th times a to the 4th times b to the 4th raised to the 4th. 3 to the 4th is 3 times 3 times 3 times 3, which is 9 times 9, or 81. A to the 4th is just a to the 4th, and b to the 4th raised to the 4th is b to the 4 times 4, or b to the 16th. So 81 a to the 4th times b to the 16th is our solution for number 6. Moving on to number 8. Again, we have 2 different variables and a coefficient out in front, so we're going to need to distribute this exponent of 3 to the 5, to the m, and to the n. But notice that n is already raised to a power, so we're going to be multiplying that exponent when we get to that term. So writing this out, we're going to have 5 cubed times m cubed times n cubed, all raised to that power of 3. 5 cubed is 5 times 5 times 5, which is 25 times 5, or 125. That gets multiplied by m cubed, and n cubed, or n to the 3, raised to a power of 3 is n to the 3 times 3. So 3 times 3 gives us 9. So this is 125 times m to the 3rd times n to the 9th. For number 10, 6yx to the 4th, all squared. So we're going to have 6 squared times y squared times x to the 4th, that quantity squared. Again, we're just taking this exponent of 2, distributing it with the 6, with the y, and with the x to the 4th, because these terms are multiplied together. I want to reiterate the fact that you cannot just distribute this squared if there was addition. So for example, if we had 6 plus x, that quantity squared, you can't just take this and distribute it in, because that is not correct. 6 plus x squared is 6 plus x times 6 plus x. So we would need to FOIL or expand out this binomial. So just to show you that it's not the same thing, 6 times 6 would be 36, plus 6 times x, which is 6x, plus x times 6, which is another 6x, plus x times x, which is x squared. So this would be 36 plus 12x plus x squared. This is not the same thing. It is not equal to just distributing the squared. If we were to just distribute the squared, that would be 36 plus x squared. What are we missing? We're missing these middle terms, and that's formed by expanding it out. So just remember, you can only distribute this exponent through when there is multiplication. If this was multiplied together, then yeah, sure, feel free to distribute that through. But you cannot distribute it through when there is addition. I just want to reiterate that because I see this mistake, which is a simple mistake, but I see it happen all the time and it's easy to avoid. So just remember, you can only distribute that exponent through when we're dealing with multiplication or division for that fact. But addition and subtraction, when there's parentheses around it and it's raised to a power, you can't just distribute through. So now that I went off on that tangent, just to reiterate a point, let's continue on with number 10. 6 squared is 36, y squared is y squared, and x to the 4th squared is x to the 4 times 2, which is x to the 8th. So we have 36 y to the 4th times x to the 8th. That's our answer for number 10. Moving on to number 12, we have 2 times x to the 4th times y to the 4th. That entire quantity is raised to a power of 4. So this is going to be equivalent to 2 to the 4th times x to the 4th raised to a power of 4 times y to the 4th raised to that power of 4. 2 to the 4th is 16. X to the 4th raised to the 4th is x to the 4 times 4, which is x to the 16th because 4 times 4 is 16th. And y is going to have that same exact exponent since 4 times 4 is 16. So we have 16x to the 16th times y to the 16th for our answer in number 12. Moving on to number 14, let's solve this 2 different ways. Let's first start by distributing this exponent of 2 to everything within our parentheses. So we'll have 2 squared times p cubed, that quantity squared, times, we'll have another 2 squared times p raised to that power of 2. Writing this out a bit further, 2 squared is 4 times p to the 3 all squared is p to the 6th because p to the 3 times 2 is p to the 6th. We're going to multiply that by 2 squared, which is 4, and that gets multiplied by p squared. Simplifying this, we can combine 4 times 4 to give us 16, but we can also combine our bases of p. Because they're the same base, we're going to add those exponents together. So this is 16p to the 6 plus 2, so we're going to get 16p to the 8th. That's our solution for number 14. Again, we could have made this a little bit easier on ourselves if we would have simplified at the start. So simplifying and then working this problem out, let's try it that way. 2 times 2 is going to be 4, and p cubed times p is p to the 3 plus 1, which is p to the 4th. So we can simplify this, what's inside of our parentheses, down to 4p to the 4th, and then we can square it. Doing that, we'll get 4 squared times p to the 4th, that quantity squared, which is going to give us the same exact thing. We're going to get 16 times p to the 4 times 2, or 16p to the 8th. So simplifying it down just made it a little bit easier to work with, but either way will give you the same exact solution. Let's continue on to number 16. In number 16, we have 3x times 2x, that quantity squared. Let's simplify at the start just to make this easier for ourselves. Combining our coefficients, 3 times 2 is equal to 6, and then combining x times x times x is x to the 1st times x to the 1st, or x to the 1 plus 1, which is x squared. And we have that entire quantity squared. So we're going to do 6 squared times x squared squared. 6 squared is 36. X squared squared is x to the 2 times 2, which is x to the 4th. So 36 x to the 4th is our solution for number 16. Let's move on to our very last problem on this worksheet, number 18. For number 18, we have 4 into the 4th times n squared. Let's simplify at the start. So we have 4 into the 4th times n within our parentheses. So into the 4th times n is n to the 4 plus 1, adding that exponent, which is n to the 5th. So within our parentheses, we're going to have 4 times n to the 5th. And that, what's in our parentheses, is then going to be squared. So we'll do 4 squared times n to the 5th, that quantity squared. 4 squared is going to be 16, and n to the 5th raised to the power of 2 is n to the 5 times 2, because we multiply those exponents. So this is going to be 16 times n to the 5 times 2, which is n to the 10th. 16 times n to the 10th is our final solution on this worksheet. If you have any questions, please feel free to leave them in the comments below, and I or one of your peers will get back to you as soon as we can. But as always, don't forget to like, subscribe, and share. Happy learning!